Today we're going to be in conversation about how different species perceive the world, what the diversity of perception tells us about the world, and what can an ever-changing world caused by humans mean for species that see, hear, smell, taste, and touch the world differently than we do. My guest for this conversation is Ed Yong. Ed Yong is a Pulitzer Prize winning science writer. He's with The Atlantic magazine. He has also won the George Polk Award for science writing. He's the author of the book that we will be in conversation about. It's called An Immense World: How Animal Senses Reveal the Hidden Realms Around Us. Ed Yong, it's a great pleasure to welcome you to this radio program.
Hi, thanks so much for having me.
Tell me about this term, Umwelt.
Yeah, so the term literally means environment in German, but the reason we're talking about it is its use in a slightly different sense. The scientist who popularized the term, Jakob von Uexküll, in the early 20th century, used it to mean not an animal's physical environment, so not the desk or the lamp or the paintings of the plants around me, but its sensory environment. So what information in its world is it capable of perceiving? And von Uexküll's crucial realization was that Umwelt, that sensory bubble, varies greatly from one species to another. So he gives the example of a tick, a blood-sucking animal. A tick's Umwelt includes the feeling of the hairs of its host's skin, the smell of its host, the warmth given off by its blood. But it doesn't include many of the things that are in our Umwelt, the sounds that we can hear, the colors that we can see. And similarly, our human Umwelt doesn't include the electric fields or the magnetic fields that many other animals are capable of sensing. So each creature is limited in their own special way, and each is only perceiving just a small sliver of the fullness of reality. And that concept, that sliver, is the Umwelt. And I think it's one of the most profound and beautiful concepts in all of biology.
I'd like to stay with this German zoologist, Jakob von Uexküll, if I'm saying his name correctly.
Your guess is as good as mine. I apologize to German speakers who might be listening for my butchering of his name.
He's early 20th century doing this work. What's
That's
important about what's important about the work that he's doing, other than coming up with this term that we've talked about, Umwelt?
So it's important for a couple of reasons. First, it grants animals the existence of their own subjective reality. I think at a time when a lot of people are seeing animals as just automata, as sort of mindless drones going about these pre-programmed behaviors, von Uexküll's concept really instantiates the idea that they have these subjective experiences in their own right, and also that those experiences are worth thinking about. It's striking, really, that he chose the tick as his example, in a very simple creature, a creature that most of us would loathe, but he's talking about the tick's subjective world. And that's, a thing that I think a lot of people still don't do in the early 21st century, let alone in the early 20th. One of the reasons I think the Umwelt concept is so powerful is it really is a very leveling experience. Von Uexküll wasn't arguing that the human Umwelt is like better, superior than that of a dog or a crow or any other creature. It just is. Each Umwelt is different in its own right. And crucially, each Umwelt is limited in its own way. So nothing senses everything, and nothing has a need to. So other creatures, when we think about the senses, we often think about other creatures having these extraordinary abilities. Dogs with their incredible sense of smell, turtles sensing the Earth's magnetic field, and we care about them when their abilities exceed ours. But von Uexküll's argument was essentially that these other sensory worlds are incredible. Regardless, like even the ticks is really interesting, even though it feels narrower than that of a human.
This seems very interesting and very important to me because I think when we see other creatures, whether it be insects, maybe a fly stuck on a window that's actually open, but it doesn't actually go outside even though you could tell it wants to, or if you see insects trapped in a particular situation in which we can obviously perceive a way out of, I think we have a sense of seeing them as just these automatons or robots that are incapable of and not smart enough or conscious enough, quote unquote, to be able to deal with the situation. When I guess the reality is this is more about the way we perceive the world and what their perceptions are telling them.
Yeah, absolutely. I think there's a couple of things happening there. Firstly, we have created worlds that are very different to those in which other animals have evolved in, right? So a lot of insects that live near water rely on polarized light that reflects off the water surface as a guide to tell them where to lay their eggs. Now, the roofs of cars and solar panels also reflect polarized light. So a lot of aquatic insects end up futilely laying eggs on those surfaces instead. That's an example of us creating a sensory world that acts as a trap, an illusion for other creatures. Our windows might well do the same. Like, what other examples are there in nature of a perfectly transparent vertical surface? There aren't any. But then also, we miss some of the incredible things that even simple organisms like insects are doing because we don't perceive their world. So, a fly's two antennae, which are so small that we can't even see them, act as small thermometers. Flies can tell the difference between the temperatures of its two antennae, and they can use that temperature difference to navigate around little micro differences in the air around them. So for us, it feels like this room I'm sitting in has just one uniform temperature. For a fly, that's not the case. It might be that one patch of air is harmfully hot to it, and another is pleasingly cool. And with its antennae, it can zip around and find those differences. So, if you know that, then when you watch a fly seemingly flying erratically around a room, like, is it really flying erratically, or is it reading the temperature differences in that room? Another example, right? Like, insects can see ultraviolet light that we cannot see. And to them, flowers are going to look very, very different. A lot of flowers have ultraviolet markings on them that guide pollinating insects like butterflies and a lot of flies to sources of pollen. The flowers will have bullseyes around their centers or arrows pointing towards the pollen sources. So here is another example of insects seeing an entire realm of colors that we can't see and seeing messages in the natural world that are invisible to us. So yeah, I think that insects and spiders and a lot of animals that we don't really think of with the huge amount of like awe or fondness feature heavily in an immense world. And I think because their sensory worlds are truly extraordinary in ways that I think most of us don't realize.
I just really want to hammer on this point. I think people oftentimes, and maybe I may have been guilty of this as well, and maybe I'm trying to blame it on everyone else, but I do think people oftentimes look at other creatures, whatever creatures they could be, squirrels in a park or taking your dog on a walk or insects, whatever it may be. We do, I think, tend to see other creatures, their movement around as being, as you said, erratic or random without purpose. But what I get from what you're writing about is that what's really going on is they're moving around based on their sensory perception, much of which we can't perceive ourselves.
Absolutely. In the 1950s, some German scientists did these classic experiments with songbirds, with European robins, and they show that captive robins, when it comes time to migrate, behave restlessly. They have this kind of migration anxiety. They know it's time to get going, but crucially, they know where to go. Even if you lock the robin in a sealed room with no visual landmarks and put it in a cage, it will hop in the right direction of its migration path. It can't see the sun, it can't see any visual landmarks. It does that because it can read the Earth's magnetic field, because it has some kind of internal compass whose workings we still don't really understand, that tells it which direction to go. Now, you look at a robin hopping about in a cage and you might think, like these are random erratic movements. But it's only when you really look at it that you realize, no, they're all in one direction. It's got a heading. It knows which way to go. The same could be said about a fly zipping around a room, or like when I walk my dog. So I have a corgi named Typo. When we go for a walk, and I'm sure dog owners listening to this will sympathize with this, there's always several moments in every walk where he's trotting along happily, and then he just screeches to a halt and really intently sniffs some bit of ground, some patch of earth, some part of sidewalk that looks completely nondescript to me. I can't see anything there. It's not like he's sniffing a thing, but there is some trace of scent on that ground that he can detect and that I have walked right past. And that, I think, is one of the true joys of this area of study, and why An Immense World is subtitled How Animal Senses Reveal the Hidden Worlds Around Us. That I think by cueing ourselves into what other animals are doing, we begin to appreciate how much we're missing in the world around ourselves. By watching a fly, I can sense that I can not physically sense, but I can appreciate the temperature gradients in the air around me. I can get a sense of the colors that in flowers that I can't see. By looking at my dog, I can tap into this world of swirling odors that my nose either is too insensitive or too far from the ground to detect. And so in all these ways, I start perceiving the world around me in newly magical ways. I understand that even the most boring and everyday environments that I plod my way through are actually full of curiosity and wonder and awe.
Frequently, I see dog owners dragging their dogs along.
Right. Yeah. Yeah, I mean, yes, it's an extremely common thing. And look, as a dog owner, I sympathize. Sometimes, I want to walk. Sometimes I want to go somewhere. DC is full of mosquitoes in the summer, so standing around in one place for any time too long is a bad idea. And yet, if I dragged Typo along with me, if I forced him to just walk at my pace every time we go outside, I am depriving him of a really important part of his doghood. His nose matters to him. His sense of smell is as primary to him as my sense of vision is to me. And so, it's as if I was going on a walk with a friend on a beautiful nature trail. And every time I stopped to look at a bird I saw, to gaze at a viewpoint, I got yanked along by my neck and told to not look. That's the experience of dogs who are being pulled along on every single walk. So every day, at least once a day, we try and give Typo a sniff walk, a walk that is his to control, where he sets the pace and he gets to sniff to his heart's content. And it's really stunning that when we let him do this, he absolutely takes his time. We might maybe spend half an hour doing one lap of our block. He can spend 5 minutes sniffing like one particular plant or one particular stretch of wall. And, for him, it's an adventure. It's his way of exploring, of getting up to date with what's changing in his world. It's also a profoundly social activity. When I scroll through my Instagram or Twitter feed and catch up on what my friends and contacts have been up to, well, that's exactly what Typo is doing when he sniffs patches of pee on our walk. He knows which of the neighborhood dogs, many of whom are his friends, have been past that area. From their scent, he can probably tell stuff about them, what they've eaten recently. Are they in good health or are they feeling unwell? It's a very, very social activity, and it's very much like my experience of checking my social media feeds. So, it's ironic again when you see dog owners looking at their phone on a walk while dragging their dog behind them. It's them taking part in an activity that they are actually depriving their dog of.
Are there consequences of depriving creatures, dogs, whatever it may be? Well, obviously there's a bigger discussion to be had about with sensory pollution, which I'm going to ask you in a moment about. But maybe let's just stick with the dog, because we do get a sense of a dog's emotional life, I suppose. Are there consequences to depriving a dog of its sensory perceptions?
Yeah, I think so. Alexandra Horowitz, who's a dog cognition researcher, who, by the way, for people listening, has an amazing book called A Year of the Puppy coming out in September. You should definitely check that out. But her writing is excellent, and she does work with dogs. And she did an experiment showing that dogs who have a chance to engage in sniffing, who get to go to like scent work, nose work classes, are more optimistic. They're less anxious by by any telling of it. I think you would describe them as happier. And we've raised Typo in that way throughout his entire life, and it's really interesting to me that like when we take him to a dog park, he spends a lot of time sniffing. He sniffs the ground, he sniffs other dogs in a way that I don't see other dogs doing. And I like obviously it's a N of one. It's our personal anecdote with him, but I think that it's contributed to him being a happier, calmer, more sociable little guy.
You write in your book that there have been studies and it's been shown that dogs that are deprived, some of their sensory perceptions also, once they get them, tend to calm down, become less aggressive towards other dogs.
Right, and that's one thing that Alexandra Horowitz has found. And look, I don't want to extrapolate too much from one study, right? Like I think if you've got a dog with behavioral problems, I'm not saying like let him sniff a lot and it'll be cured, but I do think that it makes a difference, right? It makes a difference to a dog's psychology in positive ways. And I can only encourage it. We at home we also play sniff games with Typo. Since he was a kid, we do a little game where we get him to sit in the corner of the room. We hide a piece of kibble under a toy or behind a piece of furniture, and then tell him to go find it. And it was extraordinary just how quickly he learned the rules of the game. Like with very, very little training, he immediately understood what it was that we wanted him to do, and he's very good at it. And it's a fun thing for us to do with him, and I think it makes him happier.
It seems almost impossible to me, but you'll correct me if I'm wrong, of imagining how other species perceive the world. And for example, there are animals that can see both in front, to the side, and behind them all at once. Right. I mean, we have cameras, right? You see the Google car going around for the Google Maps. We have cameras that can actually do that and do that. Yet when we observe those, we still have to view them straight ahead ourselves. We can't see it all at once. With that in mind, but correct me if I'm wrong on any of that.
No, I think you're absolutely right. There are a lot of tech people, a lot of artists who are really keen to do projects which try and give people a sense of what other animals are experiencing. And I think fair play to people who are doing this, but I think in some ways it is actually fundamentally impossible. So, like you gave a great example for animals with wraparound vision. How do you transfer that onto a human which has two eyes facing forward at all times, right? I can wear goggles that show me what is happening behind me, but we're still wrapping that onto my forward-facing vision. I cannot give myself the experience of moving away from my visual world just at the same time as I move into it. Just as like a bird experiences. I can't do that. And similarly,
birds can.
I can't. Yeah, birds can, absolutely. A duck sitting on a pond doing absolutely nothing will see the entirety of the sky. That's incredible to me. And I can't duplicate that with my own eyes. I have to look around. Similarly, we have three kinds of color sensing cells in our eyes. Birds have four. And that doesn't mean that their rainbow extends on the sides. Yes, they can see ultraviolet that we can't see, but it also means that they unlock a whole dimension of colors that we cannot see. The equivalent of colors like purple or brown to us, like mixes of colors, like those exist for birds in extreme numbers. And I cannot get a sense of what that world is truly like. I can remap any one of those special bird colors onto a human color, but I can't do that for all of them because 4 into 3 just doesn't go. And similarly, I can convert some kinds of stimuli that animals can sense into ones that I can sense. So, I can you with a simple electrode, I can turn the vibrational signals of insects into audible sounds, or I can turn the electric fields that some fish can generate into audible sounds. But that does not capture the feeling of standing on a plant and feeling a chorus of insect vibrations coming through my body. It doesn't capture the feeling of being in the water and feeling the electric pulses of other electric fish abounding in that water. A noisy electric chorus that I simply cannot perceive. So, we can do a little bit of substitution, but that's very, very different to really experiencing the sensory world of other animals. To actually do that, we need always to make these feats of imagination, these informed imaginative leaps, to use another Alexandra Horowitz phrase. And I think that's partly why I am so fascinated by this area of science, that all of our research gets us so far, but it relies on our curiosity, our imagination, our ability to empathize with other creatures to take us the rest of the way.
Birds are a trip. I do a lot of bird
Yeah.
watching. I live next to a lake, Lake Merritt in Oakland. And let me just say this so people don't think I'm absolutely ignoring this when I'm talking about it. There's a great die-off that's happening actually right now at the lake because of an algae bloom out in our bay. And there's just thousands of dead aquatic animals all along the shores of the lake. It's tragic. The place I go to very frequently for a sense of awe in nature, and then suddenly you go out there and it's just a scene of death. It's quite a feeling. I have no idea if that has anything to do with sort of perceptions, but it's quite a feeling. Going out there though, and even just passing birds that are used to humans, like seagulls. I've noticed as I pass them, if I stare at them, if I'm looking at them, they look at me back, and they either fly away or don't stop looking at me until I stop looking at them. So they're connecting, and they'll do it even if I'm behind them, they'll still do it.
Yeah. Yeah, absolutely. And then you have to ask, like, what does looking at mean for a bird that has wraparound vision? I think one common
It probably
mistake that
thinks I want to
people.
eat it.
Oh, right. No, but I mean, one common mistake that people make when thinking about like animals like, say, cows or birds, is to think that the direction of the head needs to be pointing at you for the creature to be looking at you. But of course, a bird could be looking at you through the side of its face. A bird pointing off to the right has a very clear view of what you are doing, standing off to the side of it. And yeah, I think you described this. You described this lake to me before we started this interview, and I think when you look at a scene like that, there's so much going on. I've had the same experience of standing on a pier and watching the animal life of a seafront, and I've watched shorebirds probing into the sand with their beaks. Their beaks can sense the pressure waves created by their probing and use that to detect buried shellfish that are that might be beyond the reach of their bill. It's almost a kind of seismic sense every time they dip their beak into the beach. Seabirds flying overhead, a lot of those that have prominent nostrils, like albatrosses or shearwaters. To them, the surface of the water isn't flat and featureless. It's this rolling topography of odors created by food beneath the water's surface that they can pick up with their noses. If you're in a part of the world that has sea otters in it, sea otters have some of the most incredibly sensitive paws in the animal kingdom. In their dives, they can pick up sea urchins and shellfish with their eyes closed just through feel, and they do that very quickly. It is true in all of these ways. Just a seaside, I think, becomes rich with new wonders and new information. And I think about that every time I go into a new setting, whether it's a shorefront, whether it's a garden, whether it's a hillside. I think learning about the senses of other animals gives you just this constant gift of wondering, like, what actually is going on here?
This is Letters in Politics, and we are in conversation with Pulitzer Prize winning journalist Ed Yong. He is the author of the book An Immense World: How Animal Senses Reveal the Hidden Realms Around Us. I think an important thing you write about, and I think it's important for us to talk about, is sensory pollution. What is sensory pollution?
Yeah. Yeah. So humans have flooded the darkness with light and the quiet with noise, just through our normal activities. And while we don't think of these things as pollutants, they very much are. Light and noise, sensory pollution, can have really big and detrimental effects on the animals around us. So I'll just give you some examples. So the lights of lit buildings at night can distract migrating birds from their migration routes, costing them valuable energy that they can't afford to waste. Light at night can attract insects, often with fatal results. Moths famously are attracted to lights at night. But many insects are too, and that pulls pollinating insects away from plants. That hurts them even during the daytime hours. Baby turtles, once they hatch on a beach, can be drawn up towards buildings on the side of a beach with fatal results, instead of heading towards the sea, as is their actual natural want. Noise can be really detrimental too. One famous experiment done by Jesse Barber and his group involved a phantom road. They just lashed speakers up to trees near a stopover site for migrating birds and played the sounds of traffic. So there are no cars here. There's no exhaust. There's no threat of actual collisions. There's just the noise. And that alone was enough to deplete the community of birds in the area by a third, and to reduce the body weight and physical fitness of many other species that remained. So we don't think of these things as pollution, but they are. The natural world has evolved in a context where there wasn't light 24 hours a day, where there were many areas of quiet, and we have wrecked many of those dark, quiet places in a way that I think hurts us too. A lot of people hearing this have probably never really experienced genuine night or genuine quiet, because so many of us live under light polluted skies, or live in urban environments where it's so noisy that it's like being in perpetual rainfall. That's the reality for most Americans living in urban settings. And I think that not only does this harm nature, but it harms our appreciation of nature. There was a reason why in the early pandemic, people were talking about suddenly hearing a lot more birds than they were before. It wasn't like the nature's healing trope. It wasn't just that birds were flocking back into places because humans were staying indoors. It was largely because we were quieter. And when we're quieter, we can hear over longer distances, and we can hear more within that radius. And that means we become more aware of the nature that's in our own backyards. We become more familiar with it, more connected to it. Perhaps we have greater desire to appreciate it or protect it. And I think severing that connection between animals and their environment and between us and the wildlife around us is the cost of sensory pollution, and one that I think we should avoid paying.
A few weeks ago, a friend of mine said he saw a story about how city noise and urban noise has actually changed and forced birds to change their stories. And it's funny because as I was preparing for our conversation, I think he might have learned that from your piece in The Atlantic a few weeks ago. And we were sitting in a bar when he was telling me this, and I immediately thought to myself, yeah, it's like talking in a bar. When you're in a noisy bar, you also have to really simplify what you're saying. You can't get too deep or complex in the conversation that you're having. Is that what's happening with birds?
Yeah, absolutely. Some very seminal studies in the early 2000s show this, especially in Europe. There are small birds called great tits that will sing at higher frequencies. Nightingales are forced to belt out their song, singing at much higher volumes in urban environments. And since then, there's been a huge slew of research showing that urban noise forces birds to either do something different or to just leave. Their songs become less complex or higher pitched or louder. And if they can't change, and a lot of creatures can't, then they simply can't live there anymore. And so, it's not that all animals are harmed by sensory pollution. There are going to be winners and there are going to be losers. So some spiders benefit from building webs near streetlights because those lights attract other insects. Spiders can dine happily on that. But in the main, what you get is a smaller community of creatures and a more homogenized community. It's the world that the urban environment that we're familiar with, a world of like rats and pigeons and starlings. It's not a rich, biodiverse community that I think we should be living in. I think sensory pollution not only pushes a lot of creatures away, but it means that we're left with and this impoverished community left behind. I think that's another part of the cost of this. And one really crucial thing I want to point out about sensory pollution is that it is a fixable problem, and it is a rapidly fixable problem. In a lot of the ecological sins that we have added to our ledgers are very difficult to fix. If we stopped all greenhouse gas emissions today, climate change still will occur with some like leftover residual momentum to it. If we stop all plastic production today, the plastics that we have already created will continue to despoil the environment for decades to come. It doesn't break down easily. But if we wanted to stop light and noise pollution right now, we could. And in many cases, if we reduce it, if we just flick a switch, it goes away. It doesn't persist in the environment. It just stops. And that makes it an unusually easy ecological problem to try and tackle. And we can tackle it. Some solutions are obvious. Just slowing down the speed of vehicles will reduce the amount of noise. Switching off lights and noise or changing them to wavelengths that are less harmful to animals, like reds, will make a difference immediately. What we lack, of course, is political will to do any of that, because largely, I think, because we don't see these things as a problem. Light is a good thing. We want more light at night. Light equals safety and knowledge and goodness. But that's our culture talking. That's us imposing our umwelt on that of other animals. For other creatures, light at night is a problem, and it is one that we can address and should do.
And that's the point right there. We are forcing our umwelt, the way we perceive the world, onto other creatures whose umwelt and perceptions are very different.
Yeah, exactly. It's a kind of grander scale version of the forcing your dog to go on a walk and not sniff thing. It's us forgetting that other creatures live in a very different sensory world than us. Now, and of course, humans also suffer because of sensory pollution. Light at night is a problem for us too. It disrupts our circadian rhythms. There's a reason why I don't sleep with my phone in the bedroom anymore, right? I sleep better when I'm not shining a bright stream of information into my eyes late at night. But I think we underappreciate that. We underappreciate the effects of light and noise on our own bodies. And we definitely don't think about it in the context of other creatures. But if you just can remember that life on Earth evolved in the context of daily cycles of light and dark, a streak that persisted for the billions of years of the planet's history, right until maybe a couple of centuries ago. It's a very, very recent phenomenon that we've started flooding the nighttime with light. And it shouldn't be a surprise to us that it has caused harm, that it causes problems. But it's, as I've said, it's not too late to recognize that and to actually start doing something about it.
So what do you use, an old-fashioned alarm clock?
Yeah, we actually have a kind of sunrise alarm. It's slowly bright. It's a lamp that slowly brightens the room. at a specific time of the day. We also have Typo, our corgi, who acts as our alarm. He wakes me up at 6 o'clock every morning by licking my face.
Well, thank you for letting us in on there. I was just thinking when you said you don't have the phone in your room, I was like, yeah, I shouldn't have my phone in my room either. And then I was like, wait, how am I going to wake up? It's so many people's alarm clock as well.
Yeah.
When we talk about the umwelt or the sensory of other creatures, and previously we talked about the difficulty of even for us to imagine how they perceive the world. How then do we know these things about these creatures and how they perceive the world?
Yeah, that's a great question. Through millennia of scholarship and research and patient observation, a lot of it comes from scientists looking at animals doing amazing things and going, I wonder what's going on there. A lot of a lot of incredible senses have been discovered by watching animals performing feats that shouldn't be possible. So bats can navigate around dark spaces that are too dark for even the most sensitive eyes to see. How do they do it? Well, now we know that they produce high-pitched calls and listen out for the rebounding echoes and perceive the world in that way. Echolocation, a kind of biological sonar. Some scientists watched these weird fish in Africa and South America swimming backwards. How do these fish sense the presence of obstacles behind them? Well, it turns out that they produce electric fields and sense how the objects in their environment distort those fields. And that explains their incredible feats of locomotion. Some people have watched animals, from mice to hummingbirds, open their mouths as if they were screaming and no noise comes out. Well, it turns out those creatures are making ultrasonic calls, too high pitched for us to hear. I've already told you that thing about the songbirds and knowing which direction in which to migrate when it comes to migration season, even when they can't perceive any landmarks. So a lot of the time, it's people looking at animals, doing incredible things, and thinking that shouldn't be possible. I wonder what's going on there. And it's that primal act of curiosity that I think leads us to learning about these other sensory worlds.
I have often wondered about sonar, and if when an animal uses sonar to perceive their world, if the signals that they're getting back create something similar to what we actually see with light, but maybe this is one of those things we can't know.
Well, we can get some understanding of it, because obviously there are some humans who also use sonar. There are people who can echolocate, much like a bat, less skilled because they haven't been doing it for millions of years, but I write about them in the book. A lot of blind people will make clicks with their tongues and perceive the world through the surrounding echoes. So they can give you a sense of what it's like. But again, there's always going to be that subjective gap. That even if you share the same language, I don't know what the experience of a blind person who's been blind from birth is when they echolocate, because our shared language might not reflect the same kinds of things. But we do know some stuff about what echolocation is like. We know that because of the properties of sound, it works around corners and sometimes through solid matter, like through walls. We know that it's very difficult to echolocate a small object against a large background. So the blind echolocator Daniel Kish, who I talk about in the book, says that he's often asked as a kind of party trick, what is on this table right now? And that's really hard because the echoes returning from, say, like this pen currently on my desk are going to be completely overwhelmed by the larger echoes coming from the desk itself. And we know that is a challenge for bats too. Bats really struggle to find an insect perched on a leaf. A bat can echolocate a spider on a web. It can hunt. It can yank a moth out of the sky. But once the creature is on a larger background object, it becomes much harder to spot. And that's a challenge that echolocation has that vision doesn't have. But echolocation can do many things that vision can't do. Obviously, most obviously, it works in the dark, right? So a bat can yank a flying insect out of the sky in a completely sealed room with no light in it. I absolutely cannot do that. So yeah, I think one thing this reveals, and I think this is really important, is that every sense has its own strengths and weaknesses. It's not the case that these extraordinary abilities are extraordinary full stop. Like echolocation struggles with small objects on large backgrounds. It also has a very limited range in air because sound loses energy very quickly in the air. And if you want sound to make not just the outward trip to a target, but the return trip to you, it needs to be really, really loud. And even when that's the case, even though bats actually scream at ultrasonic frequencies, thank God we can't hear them, it only really works over short distances. A bat can probably detect a small moth maybe about 6 to 8 feet away, and that's about it. Whereas I can obviously see over much longer distances, but not in the dark.
What's happening in the ocean?
In the ocean, the scale gets much bigger. So sound can travel over longer distances over water. It doesn't lose energy as rapidly as in the air. And so echolocating animals in the water, namely dolphins and other toothed whales like orcas and sperm whales, can use their sonar over much greater distances. So a bat is restricted to maybe like a human body length away from itself. Whereas a dolphin can echolocate over kilometer distances. It can, and dolphins can therefore use echolocation to coordinate their movement over large dispersed pods. And we see them doing that kind of thing in the wild. The other really neat trick that underwater echolocators have is to peer inside living tissue. So sound bounces back off surfaces when their density, when there's a sudden density change. And because most of our flesh has the same sort of density as water, sound will penetrate, but it will bounce off air-filled things like our lungs or the swim bladder of a fish. It will bounce off like much denser, harder objects, like say a fish hook or a skeleton. So, a dolphin echolocating on a human could likely sense, say, the presence of a fetus inside a pregnant woman. They could likely sense the skeleton inside you. They could probably sense the lungs inside your body. Dolphins probably can sense the swim bladders inside a fish. They might even be able to tell different species of fish apart by the shape and the size of those swim bladders. It's like they're living medical scanners. They can really peer inside the targets that they're focusing their sonar upon. And that's something that no bat can do. Dolphins also have an incredible ability of detecting buried objects with their sonar in exactly this same way. To date, there is no, the US Navy has tried to do a lot of research on this. They've sponsored a lot of dolphin research for exactly this reason, but there's no military technology that can find buried mines in the seafloor better than a dolphin can.
And is this because sound travels so much farther in water that even though the ocean's so big and comparatively the number of ships, and I know there's a lot of ships out on sea, but nothing like, probably the world's freeways, how many cars there are out there. But maybe I'm wrong. But that all said, is that why we have such problems with noise in the ocean? Because you have these big vessels that create the sound that just travels really far.
Absolutely. Shipping creates a huge amount of noise in the ocean. And, while there may be fewer ships than cars, they are incredibly noisy and their noise does travel over long distances. So the effects of noise pollution on marine life have been very thoroughly documented. There's a lot of work on the use of military sonar causing several deep sea whales to beach with fatal results. Even without those sort of dramatic examples, we know that shipping noise affects whales. It puts them off from feeding areas. It drowns out their calls. It's less of a problem, I think, for the echolocators than those that rely on much deeper calls. So larger whales produce these infrasonic calls, these very deep sounds that are too low for us to hear, but that the presence of so much shipping noise means that whales hear over much shorter distances than before. There's classic work showing that the songs of the blue and finned whales, the largest animals to have ever lived, can carry over the span of an entire ocean. People have humans dipping hydrophones off the coast and of the Americas in the Atlantic have heard whales calling off the coast of Europe. Now, can whales hear each other over these distances? It's still an open question, I think. Are they communicating over those distances? Again, an open question. But I think what's clear is that those sounds carry over much less distance than they used to because they're drowned out by the presence of ships in the industrial age. And because whales live for so long, I think it's clear that there are whales who are living today for whom the ocean feels like a lonelier place. I think there are whales that will be hearing far fewer of their own kind in the water than they used to be able to, because noise pollution has shrunk the size of their sensory world. And that just feels profoundly sad to me, like very, very tragic. I think I felt a little bit of that at the start of the pandemic when my world shrunk in on itself. It felt like I was the sort of wide expanse of my life collapsed. And I think that's actually what we're doing to a lot of creatures out there simply by pumping the world full of noise and of light.
Do you think that partial reason for whales and other marine life that beach themselves, that it is noise pollution?
Yeah, I think that beaching is a very, very difficult thing to study, but I think there's some very clear evidence that a lot of extreme noises, military sonar being the classic example, can cause whales to beach. Now, what the exact mechanism is still a subject of debate, but I think the phenomenon is pretty clear. There's a really good book by Joshua Horwitz called War of the Whales, for anyone who's really interested in this particular topic.
Is it mostly noise and light pollution that gives other species trouble, or is it other forms of pollution? Obviously, there's plastic and other forms of pollution, but sensory pollution.
Sensory pollution, right? No, that's a really good question. I mean, I focus on light and noise pollution because those are the areas where there's been the most amount of research. And even then, I would say that both of these things have become really big, well studied only in the last couple of decades. Chemical pollution is almost certainly a huge thing too. We have filled the world with substances that weren't previously there, and I'm absolutely sure that those also affect the sensory worlds of other creatures, but in ways that we have barely begun to understand. There are other examples that I could give you. Sharks have been known to bite electric cables under the water because those cables give off electric fields that to a shark probably resembles prey. That's probably an example of electromagnetic sensory pollution. We know that to an echolocating bat, flat surfaces like windows often sound like water, which is why bats often crash into windows. Previously, if there was a very flat, smooth surface that returned previously, before windows existed, right, there was only really one type of surface in nature that was going to be completely flat and return that very, very distinctive kind of echo, and that was the surface of a still pond or lake. So you could totally understand why a bat could be completely confused. So yeah, there are bound to be modes of sensory pollution that operate through the many other senses that I write about in the book. It's just that we don't know about them yet because people haven't done the necessary work to look at them.
Ed Yong has been our guest. Ed Yong is a Pulitzer Prize winning journalist, and he has joined us for a conversation on his book called An Immense World: How Animals' Senses Reveal the Hidden Realms Around Us. Ed Yong, I've enjoyed our conversation very much, and I thank you.
Thanks, Mitch. Thanks for having me. Take care of yourself.